In this work, we shed the light on a new research task termed multi-person Eyeblink detection in the wild for untrimmed video. Compared with the existing work that focus on single-person scenarios, the proposed task is more realistic and have a broader application value. For example, detecting long-term Eyeblink behaviors at multi-instance level can be used to analyze attendees' attention level and emotional state change during social interactions or group activities. Now we will briefly summarize our contributions before going deeper. First, we introduce a new task called multi-person Eyeblink detection in the wild for untrimmed video. We formally define the task and take the first step to explore it. To support this new research task, we introduce the first multi-person Eyeblink detection benchmark MPEblink, featured with more realistic and challenging. We also present InstBlink, a one-stage multi-person Eyeblink detection framework that can simultaneously detect human faces, track them along the time, and do Eyeblink detection at instance level. Under this framework, features from subtasks can be effectively shared and interacted to obtain a superior performance with high running speed. Besides, we also conduct extensive experiments to demonstrate the superiority of the proposed method and reveal insights for future works. Next, we will introduce our work in detail. First, we formally define the proposed new task. We think that a good multi-person Eyeblink detection algorithm should possess two key capabilities. First, it should detect and track human instances' faces reliably to ensure the instance-level analysis ability along the whole video. Second, it should detect Eyeblink boundaries accurately within each human instance to ensure the precise awareness of their Eyeblink behaviors. Existing metrics for Eyeblink detection only focus on single-person cases without multi-instance awareness. To address this limitation, we introduced two new metrics termed InstAP and BlinkAP to give attention to both instance awareness quality and Eyeblink detection quality. Please refer to our paper for more details. To support this new research task, we construct a new benchmark MPEblink. We choose to collect data from a diverse set of unconstrained movies to meet the multi-person, unconstrained, and untrimmed characteristics. Due to the high divergence of the selected movie data source, the captured samples are also more realistic and of great challenges for effectively detecting Eyeblinks. For instance, the pose, illumination condition, and face size also differ a lot even within the same person in the same video. Moreover, because of the various types of interaction among instances, there may exist severe occlusion or people in and out scenarios, making it harder for both instance localization and their Eyeblink detection. To perform Eyeblink detection, previous methods generally take a sequential approach containing face detection, face tracking, landmark detection, and classification on the pre-extracted local eye clues within a temporal window. Such a sequential approach is hard to meet the real-time running requirement under multi-person scenarios and usually obtains an inferior performance due to the unreliable local eye clues under unconstrained cases. In this work, we present InstBlink, a one-stage multi-person Eyeblink detection framework that can simultaneously detect human faces, track them along the time and do Eyeblink detection at instance level. Under this framework, features from subtasks can be effectively shared and interacted to obtain a superior performance with high running speed. Specifically, inspired by the recent query-based methods, we use spatio-temporal instance queries to store the face and blink features of each instance within the entire video clip. Each query contains T embeddings with C channels. Each embedding generally focuses on the instance's face and Eyeblink representations in the corresponding frame. Then, we employ Query Interaction Module to enhance the spatio-temporal face and Eyeblink feature representation. Specifically, spatial interaction among queries can build strong communication among queries to better model the instance features under complex circumstances such as occlusion due to human interactions. On the other hand, applying temporal interaction within each query allows the embeddings from different frames to communicate with each other to facilitate instance tracking and model temporal Eyeblink representations of the corresponding instance. The queries will collect the highly related instance-level face and Eyeblink representations from the extracted video features in the Video Interaction Module, which is achieved by applying dynamic convolution on the ROI features. Finally, the instance-level face and eye blink predictions can be obtained simultaneously by applying task-specific heads on the shared query features. During inference, we simply merge the adjacent frame-level eye blink predictions based on a threshold to form the final interval-level eye blink predictions. The experimental results show that the proposed method is of better performance on both instance localization and eye blink detection. Besides, our method is also superior on inference speed. The time consumption is not sensitive to the number of people because of the one-stage inference property. Here we also discuss the individual effect of the model components. First, without applying temporal interaction, the performance of eye blink detection drops drastically. This indicates that temporal modeling is critical for eye blink detection in untrimmed videos. In other words, only using appearance features cannot accurately localize eye blinks. Besides, the temporal interaction can also build instance-level association among the features across frames to facilitate the instance tracking ability. Second, spatial interaction can boost inst-AP by a large margin and slightly boost blink AP, as it may build strong communication among queries to better model the instance features under complex circumstances such as occlusion due to human interactions. Besides, compared with directly using ROI features to update query, using filtered ROI features can boost both blink AP and inst-AP by a noticeable margin. We speculate that the filter operation can activate task-specific ROI features and resist background. Thus, finer face and eye blink clues can be collected to update queries. Here we study the effect of the blink head from a multitask learning perspective. As shown in the table, adding blink head can also facilitate instance localization, which demonstrates that features for face detection and tracking can also benefit from eye blink clues. Here we also give some qualitative results of the proposed method. Our method can aware the attendees without prior face detector or tracker. It can also detect instance-level eye blinks under different facial appearance and head pose with a high inference speed. Thanks for watching.